Now, the next piece of technology that was developed really came out of the need for energy. And what helped us here is, you guys remember the 1920, no, I want to say 1919, 1930s, big oil rush out of Texas. You guys remember seeing pictures of that? Big, there's just these oil rigs all over the Texas landscape. So what we decided to do is we need to figure out how to get oil out of other places. What we found out is that the ocean floor has a whole bunch of oil sitting under it. So what we had to do is develop the technology to get to that oil. So again, that's what's driving the technology. It's not really science driving the technology. It's this general need, and then we get scientific feedback. So as they're drilling, we're getting back these sediment cores from the bottom of the ocean. And here's what we found out. Interesting. We found out that the closer you are to the oceanic ridge, the younger the sediments. Which means that the sediments that are really far away from the ridge get older and older and older. And not only that, but we also found out that the oldest part of the ocean floor is only 180 million years old. Now that's a really important aspect to keep in mind. If you remember, all the way from the beginning, we looked at these core beliefs. You know, we said that the ocean crust was unchanging and that it was older than continental crust. But based on this information from the cores, what did we find out about the age of those sediments? A lot younger. So very, very young. And so this is actually a really important aspect to keep in mind, because this tells us then that our continental crust is much older than our oceanic crust. And again, as we move away from the ridge, so right here's our ridge, and then we have our trench. So we have older rocks here, and we have younger rocks here. So that's just a piece of the puzzle. It's just some basic information. So we have younger rocks at the ridge, older rocks at the trench. Why do you suppose that's true? Why would it be younger? Does it make sense that it would be younger? Simply they'd all be the same age, right? That's just something to think about. So, let's move on down. Let's go down to ocean sediments. Not only are we younger at the ridge and older at the trench, but the thickness is not the same. The thickness of those sediments is also lower at the ridge. So we have very thin layers at the ridge and very thick layers at the trench. Why is that? What's going on here? Right? These are questions that scientists are looking at. We have younger rocks at the ridge, and it's thinner than the rocks and sediments that are at the trenches. So again, why would we have that? What would cause that to happen? Well, that's how we get this new theory called seafloor spreading. And what seafloor spreading is talking about is really basic. It's just talking about the fact that we have new crust created at the ridges, and it gets destroyed at the trenches. So again, if we're having new crust being created, we have the magma welling up, and it cools. So why would the sediments here be younger than the sediments over here? So what's happening then as this new crust gets created, what is it actually doing to the crust that's already there? Pushing it down the slope in toward the trench. Okay, so this big conveyor belt. We get new crust and just simply pushes the other crust out of the way. And therefore, since it's taking that place, it hasn't been there that long, so the ocean sediments that are there are very thin. But think about it, if I keep just slowly pushing this along, it's picking up sediments along the way, so by the time it gets way over here, it's got a lot of sediment sitting on top of it. Does that make sense? All right, it's like putting a table up in the attic. Go check on it in a year. It's going to have a lot more dust than it did the day you put it in there. And it's had more time to accrue that material. And so this is basically seafloor spreading in its simplest form. Question? So that's basically it. We're creating crust at the ridge, destroying it at the trenches. And so this is our theory. And the guy who proposes this is Harry Hess. So we're looking at it. So we put this together with plate tectonic, or with continental drift, and that's how we get the whole theory of plate tectonics. Well, we're not quite ready for that yet. This answers some questions about the ocean crust, and it kind of makes sense if you think about the Atlantic Ocean and how it formed out of Pangea. It totally makes sense that this crust would have to be much younger than the continental crust. In fact, by identifying that these ocean sediments on both sides is 180 million, that tells us how far back those continents were once connected. So we can theorize then that Pangea existed almost 200 million years ago. So that's where that age comes from, is where we're able to develop this information. So again, here is a very simple model kind of, you have the new crust being created. As it's created, it pushes out to the edges. And it's just like a huge conveyor belt pushing that material away.